Hey guys, how you going? So in this particular session, I want to look specifically at the intertidal ecosystem. Now this is quite relevant for our SAC, and so I thought I might spend a bit of time just explaining the intertidal ecosystem for you so that you have a really good idea of what actually is going on in this particular ecosystem. Okay. Now we define it as being the area along the seashore that's between the high tide and the low tide. So the intertidal zone sits between the shore, which is past the high tide mark, and also between the sea or the ocean, which is past the low tide mark. And so what you would expect in this particular ecosystem is that at high tide, the whole ecosystem is submerged, and then at low tide, the whole ecosystem is emerged. That is, it is completely outside of the water. And so what you typically see is something like this image here, where you've got the shore anywhere from here onwards. This area here will never get wet unless it's by sea spray from the waves, but this particular area will never get wet because the tides will never reach past that point. And then you've also got what we call the subtides. This area here will always be wet, right? Which means it will never go below this mark where the low tide is. That region in between is the intertidal, between the tides. We also call it the littoral zone, but it's characterized by all these unique conditions because the organisms that live here, for parts of the day, they are going to be completely submerged, but for other parts of the day, they're going to be completely emerged. And so the organisms that live there, such as this barnacle or this sea star, need to adapt to the regularly changing conditions that they're going to experience each day. And so they have different methods of survival depending on the type of organism. Okay. Now, when we talk about types of ecosystems, they can vary greatly in terms of environment. The ones that you normally see are the rocky intertidal. You go there, you pick up your rock pools, you collect shells and things like that. That's the rocky intertidal. But you also have other features such as sandstone, mudflats, which you sort of see where the mangroves grow and can stretch for hundreds of meters and is really muddy. And also the beach would be also considered as an intertidal zone because even at the beach the tides would change regularly. Now, we divide the intertidal zone into three particular regions. Okay, those regions are the high tide zone, which is upper intertidal, and this region here, for most of the day, will actually be out of the water. It might get submerged for only a very small fraction of the time when the tide is at its peak. The mid-tide zone is right in the middle. And in this area here, you're going to be submerged for roughly about half the day, and you're going to be emerged for kind of the other half of the day, right? And then you've got the low tide zone, which is where you're going to be submerged for most of the day, and then only at a small section of the day are you going to be emerged or outside of the water. Anything below that is called the subtide, where it is permanently submerged, and anything above that is just the shore. Yeah. Okay. Now, with intertidal, because of the nature of the changing waves, and the zones develop their own unique habitats. They are subjected to different environments depending where along that intertidal zone you actually are. And so we want to look at a few different factors. Now, limiting factors at high tide include heat. Because you're out of the water for most of the day, the sun is going to be glaring down and it is going to create a lot of heat stress. It also includes wind. Because you are out of the water for a lot of the day, when the wind blows, it also affects you quite a lot. And so organisms there suffer from possible desiccation, drying out. And if you think about it also, they suffer from a lot of salt or salinity because whatever water is available in the high tide gets evaporated from the sun, and then the salt concentration in the seawater actually is higher than if you were down at the lower end of the shore. Okay. Now, what that means is organisms have to have particular characteristics that allow them to survive at the high tide. So these ones are more affected by abiotic factors, environmental factors, and what you are likely to see is that there is a low species richness. Very few organisms can survive. And the organisms that do survive generally are smaller. And so when you think about size being an important factor, it's that surface area to volume ratio really being able to hide away in the cracks and the crevices and reduce the amount of exposure that they have. They generally are more sessile, which means they stay still. You'll find a small periwinkle clumped into a rock in grooves or things like that, so that it can retain whatever moisture or water that is collected throughout the day. And because they don't have to worry so much about predators, they generally have fewer defense and protection. They have to worry about things like heat stress, wind stress, drying out, and salt, not fish and things like that targeting them. On the flip side, down at this end here, at the low tide, you've got a whole different set of factors that are going to be limiting. These factors include competition. The conditions are much nicer here. You don't have a lot of stress in terms of heat, wind, and desiccation, but you are going to get a lot more other organisms competing for the same food sources and resources that you have. Predation, larger predators generally will hang down here, and so you have to watch out for those predators. And also, when you think about it, wave impact, because the wave hits here and decreases in strength as it goes up the intertidal zone, around here at the low tide zone, organisms have to worry about wave impact. Now, for you and I, the wave impact is probably not going to be that big, but for a little snail hunched on a rock, that crashing wave can easily dislodge it and carry it out into the ocean, where it will get eaten by a predator. And so the characteristics here, these are biotic factors that affect these organisms. You generally get a higher species richness at the low tide zone than you would at the high tide zone because conditions are more favorable. And so there's a lot more different species that are there. And the organisms here generally are more mobile. They can move around a lot better. They also need to be able to latch onto the rocks really well. And they don't need to be as good at retaining water as the high tide zone organisms, because water is not a big stressor for them. But on the other hand, they need better defense or better protection against predators because they are more exposed to those predators. Okay. In the mid-tide zone, you get a slightly different combination of the two again. And so it's a balance between both biotic and abiotic factors. And so what you actually find is that they encounter kind of heat stress, wind, desiccation, salinity, and also competition, predation, and wave impact. But all of these factors are mild. They're not extreme factors as they would be at the high tide and at the low tide. And so it's what we call the Goldilocks theory. The conditions here are just right for most organisms to survive. And so what you kind of get is that there's a low abiotic stress, and the richness of the species is actually highest at the mid-tide zone because the conditions are most favorable, and so you have a large variety of organisms that are able to survive here. But each one has intense competition, and so you will see that for individual species, their actual population levels are actually lower. Okay. So if we divide them up, so here's the high tide mark, here is the low tide mark. Let's go with one or a few different examples of how organisms will survive. At the high tide, you've got sunlight, wind, desiccation, and salinity levels as a stressor. At the low tide, you've got competition, predation, and wave impact. Now, let me go through a few of the different organisms that you will actually see in Victoria that live along the intertidal zone. You might have seen some of these ones when you've been walking around, but we're just going to actually learn a little bit more about them. Okay, the first one, you might have seen this. They look like they're dead along the top end of the shore, but they're actually still alive, and they are called blue periwinkles. So the blue periwinkle is really small. The shell doesn't get much bigger than 1 centimeter, but on average reaches only about 4 to 5 millimeters in diameter. And these little sea snails or gastropods are very, very good at latching onto rocks. They're tiny, so they're very small. They latch onto the rocks, and at the high tide, they stick onto the rocks so intensely that they won't move until the high tide comes in and they become submerged, where they will then move around and begin to feed. So you are likely to find them at your high tide marks because they have really good adaptations to survive up in the high tide zone. Another type of sea snail called the black nerite, you might find this guy. He's a little bit bigger. He'll grow to about 1 to 1.5 centimeters in diameter, and he's got this kind of round shape. Now he is a herbivore, and he will feed on the algae that is sort of sitting along the intertidal zone, and his zone might be a little bit better. So he's not as good at surviving against the abiotic factors that occupy the high tide, so he won't be able to push all the way up the seashore, but he'll be able to get quite a fair way away, and he'll get to about halfway, right? And so you're going to find a lot of him about halfway, and he's a herbivore that feeds on algae. And one of the ways that you can actually tell is that if you flip a sea snail over, if it has a circular opening, generally they are herbivores. If it has kind of an oval opening, they are your carnivores. Now, another species of sea snails that you might find along the seashore is actually the comonella. Now, the comonella is a carnivore. You can sort of see there that he's got this kind of oval shape, and he will occupy a territory that is a little bit round about the mid-tide zone, pushing a little bit into the high tide mark. But he's a predator, so he'll come along and he'll hunt for other snails during the tides, and so he moves around quite often. And being a predator, he needs to be able to move, and he's got this little spear right at the end that allows him to rasp and puncture a hole through a lot of the other sea snails and feed on them when the tide runs out. And so he moves around a lot more. He's not as good at adapting to desiccation and heat stress, and so he kind of needs to stay round about this particular region. But you'll notice that he won't go much further, along with the black narroweye, he won't go much further than halfway where the water is more submerged. And the reason for that is because he's got a few predators of his own, things like the dog whelk. So this is kind of like the big bully of the intertidal zone. They grow up to about 5 centimeters in length or diameter, and he is a big carnivore. He stretches all the way from the bottom of the tides right up to about midway, halfway. And what he actually do is when the tide sort of runs in, he will move in to feed on other sea snails and mussels and other organisms that live on the intertidal zone. He's a lot bigger, so he's not as good at retaining water, but he will be very efficient at hunting and moving around. Okay, but he himself has to watch out because he might be subjected to another predator, which is the 11-armed sea star. The 11-armed sea star has 11 arms, as the name suggests, and he will live all the way down past the low tide mark, right up into here. And once again, sea stars and sea urchins are not very good at staying out of the water, so he needs to be submerged most of the time, but he will move between the water into the rock pools, and he'll hunt whatever organisms are there, and then when the tide comes back in, he'll actually kind of run back out. And so he is a very big predator in the intertidal zone. And so you can sort of see that the distribution can vary depending on what type of organisms you find. You can sort of see that as you sort of go further down, the size increases. Organisms can get bigger because they don't have to worry as much about retaining water. You'll also notice that these ones down here tend to be more mobile, whereas these ones up here tend to be a lot more sessile, staying still. And then in between, you'll notice that you can get anywhere up to 4 different species occupying the same range. And so that gives you an indication that right in the middle, where the conditions are really good on both ends, you have a high species richness. Whereas out on the other end, right at the high tide mark, you only get 1, and down at the low tide mark, you might get 1 or 2. And so this is just a small snapshot of what the intertidal zone actually looks like. Okay,